Okay, today's lesson is note 9.3, and what we're going to talk about is angles of elevation and depression. All right, real simple. An angle of elevation. An angle of elevation is if you're looking up at something. It is the angle that is created with a horizontal line at your eyes. Okay, so this lady here is looking up at the hot air balloon, and this angle created by her line of sight and a horizontal line, okay, from her eyes creates what's called an angle of elevation. At the same time, if the person in the hot air balloon is looking down at this lady on the ground, okay, a horizontal line with their eyes and their line of sight creates what they call an angle of depression. Okay, so an angle of elevation is looking up, and an angle of depression is looking down. All right, now if you guys notice, all horizontal lines are parallel, and if you notice our Z here, all right, so an angle of depression and an angle of elevation, okay, are always going to be congruent. All right, if you realize that would be alternate interior angles created by two parallel lines and a transversal. The transversal would represent the line of sight from those two people, one in the hot air balloon and one down on the ground. Okay, so how do we apply that? Okay, first let's just understand what angles are what here. So what we're going to do is just, I'm going to label these with an E or a D depending on if it's an elevation or depression. Let's start with this guy here. He's looking up at the top of the tree, so angle 1 would be an angle of elevation. All right, let's say there's a little bird up here or something, and it looks down at the person looking up at him. All right, that would be an angle of depression. All right, again, looking up. So the little guy up here on the tree is looking up at the flying seagulls or whatever kind of birds those are. That would be an angle of elevation. And at the same time, looking down here, angle 4 would be depression. Okay, so really not that complicated. All right, now let's go ahead and apply the angles of elevation and depression to figure out some information. All right, so you set a rock climber on a cliff at a 32-degree angle of elevation. The horizontal ground distance to the cliff is 1,000 feet. Find the line of sight distance to the rock climber. All right, so here is you. All right, here's our cliff, and up here is the rock climber. All right, so you look up and see the rock climber. Remember, you have a horizontal distance created by that horizontal line from your eyes. Okay, this angle is the angle of elevation, which is 32 degrees. It says the horizontal ground distance to the cliff is 1,000 feet. So from you to the rock is 1,000 feet. And it's asking us to find the line of sight distance to the rock climber. So this would be the line of sight right here. Line of sight. All right, this I will call X. Now, if you notice, we have a right triangle. Okay, so here's the angle we're viewing from, and there's two sides that we're dealing with. This would be the adjacent leg, and this would be the hypotenuse. Okay, so adjacent and hypotenuse would be ka, representing cosine of the angle, equals adjacent over hypotenuse. Okay, plug in the information. Cosine of 32 equals adjacent, which is 1,000, over hypotenuse, which was x. Again, if x is on the bottom, we are going to divide. So my math would be 1,000 divided by cosine 32. That should give me my my line of sight distance to the rock climber. So let me calculate that really fast. It doesn't tell me to round it, so I'm just going to use whole numbers here. And it should be approximately 1,179 feet. All right, let's try the next example. Okay. Forest ranger looking out at a ranger station could see a forest fire at a 35-degree angle of depression. The ranger's position is 100 feet above the ground. How far is it from the ranger station to the fire? So let's give ourselves a little drawing here. All right, here's our ranger station. All right, here's our ranger. And over here we have a fire. Don't make fun of my fire either. It's awesome. A little smoke coming out of it. There we go. Okay, so ranger looks down, sees the fire. Now the angle of depression is created by that horizontal line from that person's eyes. So this angle right here is our 35-degree angle. Again, the ranger's position is 100 feet above the ground. So this height right here is 100 feet. And as you can see, okay, we have a right triangle. How far is it from the ranger station to the fire? So that would be the ground length. Okay, so that's our x. First thing we're going to do is we're going to take the angle of depression and we're going to apply it down over here because that is where alternate interior angles come into play. So this is the same angle as this. Okay, so now I can disregard that. All right, here's your viewpoint. This would be the opposite leg, and this would be the adjacent leg. All right, that would be TOA. So tangent of the angle equals opposite over adjacent. Tangent 35 equals opposite over adjacent. Okay, x is on the bottom. That means you're going to divide. So x equals 100 divided by tangent 35. Okay? So let's keep everything in whole numbers for today. So 100 divided by tangent 35 is approximately 143 feet. Okay, so that represents this distance, all right, that the tower is away from the fire. All right, last example. Okay, here we have a surveyor. Surveyor measures the top of a building 50 feet away from him. So I'm going to draw my surveyor here. Here's my surveyor. And here we have a building. Throw a couple of windows on there. Maybe a door. All right. So surveyor is 50 feet away from the building. His angle measuring device, so he's got a little device here. All right, he looks through the device and you can see the top of the building. Okay, this thing is 4 feet above the ground, so there's your imaginary horizontal line. All right, the angle of elevation to the top of the building is 63 degrees, so there's our angle of elevation. How tall is the building? So the length of that building, the height of that building is our x. Okay, here's our angle. This would be opposite. Again, this would be the adjacent leg, so we're going to use TOA again. All right, that's tangent of the angle, which is 63, equals opposite, which is x, over adjacent, which is 50. X is on top, so you're going to multiply. All right, so it's tangent 63 times 50. This gives us, actually, it only gives us up to here. Okay, so let me calculate that out. Tangent 63 times 50, and we get approximately 98 feet. However, you have to account for the height of the measuring device. So I'm going to add 4 feet to that to get the actual height. of the building. So if we add 4 to that, that should give us our answer, and that looks like it's approximately 102 feet. Okay, you can try the next example, all right? You can try that on your own, all right? And we can always talk about it during class. Adriana, I hope I didn't mess up too many times there for you. Have a great day.